Hey everyone, and welcome. Today we're going to go inside the factory. But this is not your grandfather's assembly line. We're about to explore how artificial intelligence is kicking off a full-blown revolution in how we make, manage, and even think about, well, pretty much every product we use. Okay, let's dive right in.
So I want to start with just one big question. What if a factory could actually see into the future? What if it knew for sure that a machine was about to fail or a tiny defect was about to appear on a product and it could step in and prevent it? This isn't science fiction anymore. It's really the core promise of the intelligent factory.
And this slide, this sums it all up perfectly. We're seeing this massive shift from the old way, the reactive way, right? Where we basically just wait for something to break and then scramble to fix it, to a new, proactive model. The whole game now is about using data and AI to see problems coming and act before they cause any damage. The factory is becoming a system of intelligent prediction. Okay, our first stop on this tour is going to tackle one of the absolute biggest and most expensive headaches in any manufacturing operation. That moment when a critical machine just stops. I mean, just think about the dominoes falling. A single bearing fails, a motor gets a little too hot, and boom, the entire production line grinds to a halt. We're talking about unplanned downtime, and it costs industries billions, with a B, in lost productivity, blown deadlines, and crazy expensive emergency repairs. So how does AI fix this? Well, the answer is a really cool concept called predictive maintenance, or PDM. The whole idea is to get away from those rigid, old-school maintenance schedules. Instead, the AI is constantly listening to the machines, analyzing all their data, and predicting the exact moment a part is likely to fail. This lets you schedule maintenance for the perfect time, right before anything actually breaks. And here's basically how it works, in 4 simple steps. So first, the factory just listens. You've got sensors everywhere, collecting mountains of real-time data on vibration, temperature, you name it. Step 2, AI models sift through that constant data stream, and they spot these tiny, tiny patterns, things a human would never catch, that signal trouble down the road. Third, the AI predicts what it calls the remaining useful life of that part. And finally, step 4, it acts. It just automatically schedules the maintenance. It's such an elegant, data-driven solution. All right, so keeping the machines running is one thing, but what about making sure everything they produce is absolutely flawless? That brings us to our next section, AI-powered quality control. For decades, quality control meant you had people with their own 2 eyes just visually inspecting products on the line. But, humans get tired, it creates a huge bottleneck in production, and frankly, some defects on a microchip or in advanced materials are just way too small for our eyes to ever catch. So what AI brings to the table here is basically a superhuman eye. And what's amazing is that it's not a one-size-fits-all solution. You have some AI models that are so small and efficient, they can run on a tiny device right on the assembly line, giving you instant checks. Then you have other, more powerful models that can be trained on just a little bit of data to spot really subtle defects. And in things like 3D printing, the AI can even spot errors while the object is being created, layer by tiny layer. Okay, so we've covered individual machines, we've covered product quality. Now let's zoom all the way out. How do you coordinate the thousands of moving parts that make up the entire factory, the whole shebang? A modern factory it's like this massive, unbelievably complex dance. You've got robots, supply trucks arriving, worker shifts, production targets, and all of it has to be perfectly synchronized, in real time. Trying to solve that giant puzzle by hand? It's pretty much impossible. This is where a really powerful AI technique called reinforcement learning steps in. The best way to think about it is like this. You put an AI agent in charge of the factory floor. It tries out different production schedules, different routes for the robots, and every time it makes a good decision that boosts efficiency, it gets a reward. After millions of these virtual trial and error runs, it basically teaches itself to be a master choreographer, discovering the most efficient flow for the entire operation. And this isn't just theory, okay? The results are real. As this chart shows, studies that use reinforcement learning are seeing significant, measurable gains. Factories are actually increasing their throughput, that's how much stuff they can make, and they're becoming more energy efficient at the same time. It's a total win-win. But let's pump the brakes just for a second. We have to be realistic here. As powerful as this tech is, the source material is pretty clear that we're still in the early days. Most of these applications are still pilot projects, and there are big questions left.
Companies are trying to figure out if the massive upfront cost is worth the long-term savings, and how you take a system that works in one factory and scale it across a whole global network. Okay, now let's blow the doors off the factory for a minute and look at the bigger picture. Because look, making a product is only half the battle. You then have to connect that product to this huge, complex, and, let's be honest, often unpredictable global supply chain. This is the classic multi-billion-dollar balancing act, right? Supply and demand. If you make too many cars, you're suddenly stuck with billions in inventory just sitting there. Make too few, and you've got empty showrooms and angry customers. Nailing that forecast is absolutely everything. And of course, AI has a whole toolkit for this challenge. As you can see here, different AI models have different strengths. Some are just incredibly good at predicting sales. Others, like neural networks, have been shown to literally cut forecasting errors in half. And the really advanced systems, they can even adjust your inventory levels automatically, in real time. So, for our final section, let's look over the horizon. We've seen how AI is optimizing the way we make things. But what's the next great leap forward? Now, this is where things get really, really exciting. The AI is moving out of the factory and into the design studio. It's actually becoming a creative partner for engineers. People are calling it AI-augmented design. I mean, just imagine an AI that can analyze every car chassis ever designed, and then suggest a totally new one that's lighter and stronger. Or an AI that can look at a blueprint and recommend small changes that will make it way cheaper to actually manufacture. Some even use generative models, the same kind that create AI art, to invent brand new, complex shapes. It's happening right now, and it's slashing design times. So if there is one big thing you take away from all of this, let it be this fundamental shift. We are moving away from a world of reaction, of fixing what's broken, of counting defects after they're made, of guessing at demand, and we're moving into a world of intelligent prediction. And that leaves us with one final, pretty big thought to chew on. As these incredibly powerful AI systems take on more and more of the work of designing, building, and managing our physical world, what's the next great frontier for human creativity? What do we do next?